So we know he doesn't know. So these both can't be green. So that's not a possibility. All right? So when we're looking at what hats we're looking at, we have different combinations of outcomes. We can have a green, and this guy has a red, or this guy has a red, and then there's a green, or we can have them both be red. Do you agree that those are all of our possibilities? All right, let's start ruling out. Let's start talking about what can't be. Who knows one scenario that can't be true? Gotcha.
It can't be red and green because then the third person would know that they have. Oh wait, no, that's not true.
Okay, go ahead.
The first person can't have green, because then the second person would know that they have red.
Okay, so this person says, I don't know what I have on. So these guys both know they don't both have green, right? So if he sees him having green, he would know that he has red, and he doesn't know, right? So because of what he says, everybody knows that these are our only possibilities, right? He's looking, and he knows that this guy here knows that they either both have red or they have green and red. So because he sees the guy's hat in front of him, he doesn't know what he has. If this guy has green, he'd know he had red, and because he doesn't know what he has, that guy can't have green. Do we match? Do you understand that logic? Okay. Here's the crazy part. We can stop here. Because nobody asked us what guy number 2 has. He doesn't know. The only thing we're asked to find out is what guy number 1 has. So no matter what, he's got red. Do you see it, Mason? You're going to go through it one more time. Okay, are you ready for this? If these were both green, this guy would know he has red. But that's not the case. Which means that one of these guys either has one green, one red, because remember, it's not green, green. So it's either green, red, red, green, red, red, green, or red, and let me copy this, red, red. So those are our possibilities. If this guy looked ahead and said, oh, I see he has green, that means I must have red, the story would be over. But he doesn't know what he has, so this possibility is out. So this guy could have green or red. This guy could have green or red. We don't know what 2 and 3 have, but this guy says, I know what I have to have red. Because look, those are the only choices left. You see it now? It's one of my favorite problems. Hey, put this in front of your parents tonight. See if they can figure it out. Write your answer down somewhere where you can either fold it or hide it. Like this, be like, hey, Mom, Dad, look at this puzzle. See if they can get it. And when they go, time for that. It's like, imagine how I feel. I'm in this lady's class. Right? Give them a little taste of what we're looking at in geometry. And let them have a good time with it, for sure. All right, so we talked about the front. We talked about the back. Next thing we're going to talk about is I'm going to put you back into your notes 2-5. Would you please take out notes 2-5? You should have them. If you don't have them, I might have 2 extra copies, but you should have them from the past. It should be very organized. Notes 2-5. Alright, so I know we talked about these before. I know we talked about these. Oh, sorry. Oh, wait, okay. I know we talked about these before, but we're going to go back and talk about them again. Did everybody fine? Check in with your partner. So you know what happened last year that absolutely sent me off the edge? One person said, I don't have it. And I said, okay. And I walked over here. And I'm very organized. So it took me no time at all to find the notes. So I gave that person the notes they were missing. And then I started teaching. And in the middle of my concept, where I was trying to talk about something, guess what happened? No, he didn't find it. Somebody else went, I don't have a note. So I'm like, Friday afternoon, it's Friday morning. I don't understand why I'm more organized than you, so okay. So I'll go ahead and give you notes. And then, while I'm in the middle of teaching, I jump back into my concept. You know how you hate to be interrupted? You got your head when you're talking and thinking about it. And then I was in the middle, and I asked a question. And I was so excited for somebody to answer the question, hand in the air. I was like, lay it on me, what do you know? And what do you think they said? Do another copy of that. And I was like, that child may or may not be headless right now. Because there may be a chance that I did it all. Why are you holding it? Is that what I gave you? That's not. I'm out of copies. So now I'm short a copy, which means all of my extras have been taken. It's your lucky day. Are we good? Are there any children's heads at risk this afternoon? Part of the dangers of being in the front row, y'all. Okay, ready? Vertical angles theorem. This is what you need to understand about why we're doing what we're doing. Hey, this is our first one of these. This is our first one of these. Our vertical angles theorem, a theorem is something that can be proven. So something that, oops, that's not what I want to do. Something that can be proven. So what Euclid has done is our theorems are going to represent all kinds of shortcuts for us. We have our definitions, we have our postulates, we have our properties, and what we can do is we can use them to prove the theorems. Hey, once we use it, once we prove it, we can use it. So that's exciting because now, if I can prove to everybody how I know that vertical angles are congruent, I can use that every single day in my proof instead of all the stuff that builds up to it. You're like, we kind of already knew that, didn't we? No, we didn't. We've been kind of cheating the system so far. Here's what we did know. We knew that the definition of vertical angles was two angles that had a common vertex with no common sides. We knew that if we had two angles that shared the vertex and non-common sides, we knew we had vertical angles. That's the definition of vertical angles. In no part of that definition does it tell us that they're congruent. We've kind of been cheating. So when I rewrite my vertical angles theorem as a statement, I could say if two angles are vertical, then they are congruent. Question for you, do you think it's biconditional? Mason shook his head no. How come?
Because if they are congruent, that doesn't mean that they're vertical.
We got lots of congruent angles, but that doesn't mean that they're vertical. Okay? So no, it's not a biconditional theorem. But when we talk about how we could potentially go about proving it, an interesting conversation might be to start talking about our linear pairs. Name me two angles that are a linear pair. Call it out, Emery. 1 and 2. Name another angle that's a linear pair with 2. Say it out loud. 1 to 3? 3. Do you see here that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees? Boy, did I just take a bunch of leaps. I said 1 and 2 are a linear pair. If they're a linear pair, they're supplementary. If they're supplementary, they add to 180 degrees. Those 3 steps need to be acknowledged. Nod your heads and go, got it. I didn't hear a single got it. Got it. Okay. Measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. How do I know that's true? They're a linear pair. All linear pairs are supplementary. Angles that are supplementary add to 180 degrees. Where do you see this witchcraft? You ready? Measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. What is that witchcraft? What did I do? What did I do? Come on, put your brain on. Figure it out. I should be able to smell smoke. What did I do? What do you think, Sumner? What did I do?
You subtracted.
Nope. What did I do, Emery? So the law of Phillips-Johnson is the law of logic taken into a property. Which property is the application syllogism? Sully, you got it? Begins with a T, ends with a transitive. You got it. That is a transitive property of equality. So because 1 and 2 is equal to 180, if I wanted to be crazy, I could say we needed to use a symmetric property equality to flip that around. We're not going to go there. This is equal to 180, this is 100 equal, so I can set them equal to each other. Who sees what I can do now? Do you see it, Emery? What? Measure of angle 2, subtract that from each side. Measure of angle 1 is equal to measure of angle 3. Boom! Definition of congruence says those angles are congruent. Hey, you have a choice. Do you want to use this little rule every single time you need it, or do you want to go through all of this work? That little rule. That's a theorem that we can prove. Congruent supplements theorem is our next angle theorem, and that's the one that says this. If two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. Oh, you might need to write this one out in symbols. Hey, I'm going to give you some givens. Angle 1 and angle 2 have the same measure. They are supplementary to angle 3. Let's rewrite this using symbols. Are you ready? The measure of angle 1 plus the measure of angle 3 is equal to what? Yeah, because they're supplementary. How do I know that? Definition supplementary. You have to imagine that little kid in the back of your brain going, how? What? Says who? Does mom know? The measure of angle 2 plus the measure of angle 3, whoops, is equal to what? Why? How? Who told you? They are supplementary, so the definition of supplementary is angles that add up to 180 degrees. Talk to your partner. How could you finish this guy off? Go. Talk to your partner. Do you have it? Go ahead. How do you finish it off?
When we got the notes, we did the study. Yeah, we did all of it.
Oh, teacher. So Dritza got this next step, and then I heard one more, and I think, what did you just say? Or is that you, Scott? Go ahead, Scott. What did you say?
The 3.
Yeah. Subtract that from each side. Suddenly I've got the measure of angle 1 is equal to the measure of angle 2. Go back and read it. If two angles are supplements of the same angle, then the two angles are congruent. If two angles are supplementary to the same angle, then those two angles are congruent. Got it. Congruent supplements theorem. Hey, I got a question for you. Is this one biconditional? Tanner, what do you think? Let me read it both ways, and you give me a thumbs up, yes or no. Ready? If two angles are supplements of the same angle, then the angles are congruent. We just proved it. Thumbs up. All right, he's halfway there. Are you ready for the converse? If two angles are congruent, they're supplements of the same angle. Biconditional. Two angles are congruent. Here's my congruent angles. They have the same measure. Are they both going to be supplementary to the same angle?
Yeah.
Yeah. Yeah. This guy's biconditional. How fun is that? He's got it. Hey, congruent complements theorem. What is the only thing different between the congruent supplements and the congruent complements theorem? What's the only difference? Yeah. So instead of things adding up to 180 degrees, now we've got 90 degrees. So it says, we write it using symbols. If the measure of angle 1 plus the measure of angle, this time it looks like 1 and 3 are congruent angles. And the measure of angle 3 plus the measure of angle 2 equals 90 degrees. If that's true, then the measure of angle 1 is going to be equal to the measure of angle 2. And how could you prove it? Something equal to 90 degrees. Little transitive property of equality. You could have also called that substitution, by the way. Anybody itching to call it substitution? I would have bought it. subtract the same thing from both sides. It's 2 like a day. Are we good?
Wait, wouldn't it be the measure of angle 1 equals the measure of angle 3?
What? Yes. Go put a smarty up. Is that you, Donovan?
Yeah.
Donovan's earning you guys candy. Everybody say thank you, Donovan. Okay. I love these right angle theorems. And they are ones that are easy to prove. Number 1, all right angles are congruent. Let's talk about this. The definition of right angles says if the measure of an angle is equal to 90 degrees, then it is a right angle. Definition of right angle is a 90 degree angle. So if every right angle is 90 degrees, then doesn't that make sense that all right angles are going to be congruent? So how to prove that? Use the definition of right angles. So we can talk about measure of angle 1 is equal to 90 degrees. Measure of angle 2 is equal to 90 degrees. Therefore, measure of angle 1 is equal to the measure of angle 2. Definition of congruence, they're congruent. Okay, all right angles are congruent. Got it. If 2 angles are congruent and supplementary, then each angle is a right angle. Congruent and supplementary. Let's break that down. Congruent means that they have the same measure. Supplementary means they add to 180 degrees. So if I want to prove that each is a right angle, by definition I have to set up an equation and get my angle measure equal to 90 degrees. Turn and ask your partner, what equation says this? Go.
No, I already know it. What's the rate of class?
Find the equation of 2 degrees.
8.
Yeah. Go. Well, because what we want to do is bring subtract this, right? So if you did these in together, it's okay. Yeah, you can copy this and put it anywhere you want. All right. Hey, my angles are congruent, so I know that the measure of angle 1. I'm bringing things to work. Huh. What's going on with my board? Uh-oh. Oh, there it is. Hey, because I know that 1 is congruent to 2, I know that their measures are equal. That's the definition of congruence. Once I know the measures are equal, is everybody okay if I just come down and substitute? And then I'm like, oh wait, I gotta clean this up. Because I have 2 of them. Oh wait, I can divide each side. Check that out. I wanted to try to get it so the angle was equal to 90 degrees. And look at what I did. I did it. Look, look, look. If 1 and 2 are equal, then I can substitute 1 in for 2. Substitution property solved. Measure angle 1 plus measure angle 1. I can clean that up. I can combine those like terms. Hey, how many measures of angle 1 do you have? Oh wait, I can divide that too. Divide each side. Now measure angle 1 is kind of cool, right? Alright. Are you overwhelmed by all of the different things that I'm throwing at you? Definition of this. Do this. Add this. This rule. This postulate. This whatever. So what we have is an opportunity for you to get yourself a little organized today. It goes like this. When I can't decide what to cook for dinner, we have a pantry. So I open up the pantry and I just look at it and I'm trying for ideas. I'm seeing some taco shells, seasoning, chips, salsa. What am I thinking?
Tacos and nachos.
Sounds like I'm having tacos, right? So I didn't know what I wanted to have for dinner until I walked into the pantry and I'm like, ooh, we have those shells. Ooh, we have that seasoning. Ooh, we have salsa. And whoop, we have chips. So I'm looking in my pantry, and from the choices, I get an idea of what to cook for dinner. Does that make sense to you? Now, also in the pantry is some beets that Mr. Glacier loves to buy. Coconut milk, pasta, tomato sauce, oregano. Any of that going in my tacos? Good Lord, no. But it's there in the pantry, maybe for tomorrow or next dinner. So what we're going to do is we're going to introduce to you guys a concept of a proof pantry. You and your partner are going to have a very heartfelt, personal conversation right now, and you're going to decide which one of you is more organized. Now, hold on.
Don't point fingers.
Hold on. Hold on.
Don't point fingers at me.
Don't start.
Paper. I don't even know where this one goes. I lost one. Literally, simultaneously getting to spiral. It's somewhere at the bottom of my bag.
I just totally forget everything.
Oh, wait. Okay. Listen to your instructions. You don't know what they are yet. Still waiting. So, what we're having you create, we're calling, for lack of a better term, a proof pantry. And the proof pantry is just to provide a closet full of things that you may or may not need to use when you're doing your proofs. So if you look back to all the things that I just threw at you, definition of right angle, definition of supplementary, definition of congruence, subtractor property of equality, those are all things that you can use as justifications. So what we're going to do right now is organize a list of things that you can use as justifications. So when you're looking at a proof and you can't quite figure it out, maybe taking a peek at your proof pantry and saying, okay, what do we have? The segment addition postulate. I got it. That's the one that says I can add two segments together. Now, this piece of paper is just for you. You're not turning it in. You're not getting points for it. Nothing along those lines. What you are going to do is create a resource. If you don't know what seg add stands for, then it's your job to write the segmentation postulate. If you don't know what this stands for, then you need to write out angle addition postulates. Because our theorems are proven when we combine properties, definitions, postulates, and their rules of logic. Now, the rules of logic is a short column. We've got detachment. We've got syllogism. But the understanding is, and what Euclid's goal for us was, if we had precise definitions, postulates, givens, we can use those things to prove hundreds and hundreds and hundreds of theorems and truths that we can figure out. Now, when we talk about definitions, you could start and list 30 definitions for this whole page. But start thinking about the ones that you start hearing over and over again. Your number one definition that you hear all the time is the definition of congruence. You hear supplementary, complementary, right angle, midpoints, bisector. Whatever these proofs are having you do, that's what you add. So what I'm going to do, my question for you is, which one's more organized? Have one partner take out their notebook, and what I'd like you to do is I'd like you to page through from day one of geometry. And if you think there's something in your notes that would be a really good justification in a proof, write it down. Is it a property? So far, you've already seen examples of us adding the same thing to each side, subtracting the same thing from each side, multiplying the same thing from each side, and dividing the same thing from each side. You've also seen us substitute. So those properties, pretty important for sure. So what I'm going to do is take the next 5 minutes, page through whoever's notebook is more organized, pick one of you, look at all of our definitions, and fill in some things on your proof pantry. Questions before I let you go? You can fill it out however you want. No. So, Serena asks a good question. Listen up. Listen up. Serena asks a good question. She's like, do all these things add up to something I should know? No. This is just a list of theorems, a list of rules of logic, a list of postulates. You're thinking the pantry. When you open up the pantry, it's all the stuff that you have a possibility of using. Make sense? Go.
What is combining like terms?
Where is what term?
Combining like terms.
We can call that one of our properties. Go ahead. Anything else? All right, take 5 minutes. Go. Okay, here's how this works. Everyone's proof pantry is going to look differently because it's your resource for you. And we put it on a colored piece of paper so that it sticks out so you can be like, oh wait, snap, I need to add something to it. So every time that you want to make sure that you know what your choices are for justification, this pink piece of paper, that's your proof pantry, is going to be your number one resource. So if you can't figure out why things are the way they are, go ahead and go take a look at this piece of paper and see if it helps you out. Now here's the thing. You're going to keep adding to it all year. Because each time we learn something new, it's like we're stocking the pantry with more different cool things for you to be able to use in your proofs. So whatever abbreviations you use, make sure you understand. If you're working with your friends and you're like, oh, I don't think I have the definition of midpoint in my pantry, let me quick add that. So postulates, do you have segment addition? Do you have angle addition? Do you have linear pair? Do you have your protractor postulate? Do you have your segment postulate? Those are all the rules that we had when we talk about the things that we can do. Okay, Here's what I just passed out to you now, and everyone's freaking out about the different highlighting. So would you please look at your paper, and your highlighting determines what group you're in. Okay? Some of you have this first page with this yellow highlight. Careful now, you're in the yellow group. Some of you have the second page with this green highlighting. What group do you think you're in? Yeah. Some of you have this third page where you have pink highlighting. What group are you in? Some of you have this back page with the purple. What group are you in? Okay. So here's the deal. This is supposed to be an activity that we do next week, but since I will not be here, I want to explain to you the activity now so that you can do it with the substitutes. Sound okay? Okay. So this is what we're doing. By the end of next week, all of these proofs in this packet will be filled out and complete. You're responsible. You are having a quiz the next class that we have after our next class. Which class is? On one of these proofs. So it's going to be a quiz, and it's going to be luck of the draw. So somebody's going to get proof 1, somebody's going to get proof 2, proof 2. So the quiz will consist of these proofs. You get one. Does that make sense? So you want to know how to do it. But to us, handing you a packet of proofs and saying, go, figure it out, is very frustrating for a geometry student. So what we're doing is we're going to put you into groups and we're going to do what's called a jigsaw. Pay attention. The yellow group is going to meet with the yellow group, the green group, purple group, green group, and you're all going to figure out your group. You're going to become the expert, and you're going to agree on asking questions if you need on how to do your proof. When you come back to class next, believe it or not, I don't see you again for a week. When you come back to class next, you are going to be the expert of that pink proof, green proof, yellow proof, purple proof. The substitute is going to put you into groups of one of each color. So you're going to listen to the yellow person explain the yellow proof, and you're going to be like, oh, I get it. Asking questions if need be. You're going to listen to the green person explain the green proof, and you're going to be like, oh, I have a question. And then you're going to feel good about it. Now when it's your turn, you're going to be the expert and explain your proof. So the work we're doing today makes next class's activity sound good. Are we okay with that? Okay. So let me go over with you what your homework is for tonight, so we are on the same page with that. The back of notes 2-5 has some angle conversations, and it has a proof. That is homework. So the back of notes 2-5 is homework. You also had this worksheet that was called, please don't talk, please don't talk. You also had a worksheet that was called Proof Practice 2. We went over the front of it. And in fact, you can go ahead and look at some of the things that we use as justification. So if you don't have midpoint under your definitions, add it. Put it in your proof pantry. I would like you to do the back of proof practice number 2. If you've got these worksheets, they're all posted on Schoology. If you don't have a printer, you can do them on a piece of notebook paper. Does that make sense to you? All right, so what I want you to do is I want to give you at least 15 minutes working with your group. So what you're going to do is pack everything up. I don't have any more papers to hand out to you today. And I'm going to put you with your groups so that you can talk about your groups. I can't hear the one person I gave permission to talk. The next quiz is on your sheet. up on your sheet when it talks about your proof quiz. See it? Everybody okay? All right, if you are a yellow group member, I'm still talking. If you're a yellow group member, you're going to come up to this front corner and arrange the desks or the chairs so that everybody's in a circle, able to talk. Hold on. If you're green, you're in the back corner. Pink,